In the last video, we built the generator, the forger, but every forger needs someone to challenge them. Enter the discriminator, the art detective. Its job: look at any image and decide real or fake. Let's go inside the detective's mind. When an image reaches the discriminator, it doesn't see a face or a landscape. It sees a grid of numbers, pixel values between -1 and 1. The discriminator's job is to look at these raw numbers and find patterns. Real images have a certain texture, certain statistical signatures that fakes often miss. Subtle noise patterns, color distributions, edge sharpness. The discriminator learns to spot these tells. It's like a detective noticing that the paint smells wrong. The discriminator is essentially a convolutional neural network, a CNN. But while the generator builds up from small to large, the discriminator does the exact opposite. It takes a full-sized image and shrinks it down layer by layer. Each convolutional layer uses small filters, usually 4 by 4, that slide across the image, detecting features. Early layers detect simple things, edges and textures. Deeper layers detect complex things, eyes, symmetry, realistic lighting. By the end, the entire image is compressed into a single number, the probability that the image is real. Instead of max pooling, the discriminator uses strided convolutions. A stride of 2 means the filter jumps 2 pixels at a time instead of 1. This naturally halves the spatial dimensions at each layer. Why strided convolutions instead of pooling? Because they are learnable. The network gets to decide how to downsample rather than just taking the maximum value. Each layer has more filters but smaller spatial size, trading space for depth of understanding. 64 filters at 32 by 32, then 108 at 16 by 16, then 256 at 8 by 8. The discriminator has its own tricks for stability. Instead of regular ReLU, it uses leaky ReLU. Regular ReLU kills any negative values, sets them to 0, but leaky ReLU lets a small negative slope through. Why? Because the discriminator needs gradient flow even for negative activations. Dead neurons are the enemy. And just like the generator, it uses batch normalization, but with one key difference. The first layer usually skips batch norm. This lets the discriminator see the raw pixel distribution without any normalization distortion. At the very end of the discriminator, all those feature maps get flattened into a single vector. Then a sigmoid function squeezes it into a value between 0 and 1. 0 means the image is definitely fake, 1 means it's definitely real, and everything in between is the discriminator's confidence level. Think of it as a lie detector score. 0.9 means I'm 90% sure this is real. 0.1 means nice try, generator. This single number is what drives the entire GAN training loop. The discriminator's training is beautifully simple. It sees two kinds of images, real ones from the training dataset and fakes from the generator. For real images, it should output 1. For fakes, it should output 0. The loss function, binary cross entropy, penalizes wrong answers. If it calls a real image fake or a fake image real, the loss goes up. Through backpropagation, the discriminator sharpens its detective skills. It learns the subtle patterns that separate authentic work from forgeries. But here is the catch: as the generator improves, the discriminator's job gets harder. Now let's see how both networks work together. The generator creates a fake, the discriminator judges it. If the discriminator catches it, the generator gets feedback and improves. If the discriminator is fooled, it gets feedback and sharpens. They push each other in an endless arms race. The generator gets better at forging. The discriminator gets better at detecting at a produces images so real that the discriminator can do no better than a coin flip, 50-50. That's when the GAN has truly learned. So that's the discriminator, a sharp-eyed detective that drives the entire GAN system. In our next video, we'll bring both networks together and explore the full training process, the adversarial game itself. Stay curious.